So in today's class, we are going to study about the introduction to IIR digital filter. So we are going to focus on IIR filter design. Just one second. Then we are going to focus on IIR digital filter design. So what is meant by IIR filter? IIR is nothing but the filter which is having infinite number of samples of impulse response. We call it as IIR filter. So here the main purpose of IIR filter, digital filter design is we have to convert the analog filter into a digital filter. So for that we have to design the filter. This IIR filter does not have any kind of very special filter. We will be using this low pass, high pass, band pass and band stop only. These filters only. So actually filtering is nothing but it is a very important concept in the signal processing. So the filter is the one which allows only the specific frequency to pass through and does not allow attenuate any not allow any other frequencies to pass through. So the digital filter in the sense when the discrete time system is used for the treatment of discrete time signal, then we call it as a digital filter. So when we classify the digital filter, so we can classify it as classical filters, modern filters like that. So classical filters are frequency selective filters. So it will eliminate a particular frequency or it will allow only particular frequency. So that's why we call it as the classical filters. But modern filters here, the signal is aliased into the interferer frequency component. So when we classify the digital filter according to the magnitude characteristics of the transfer function, so we can classify it as low pass, high pass, band pass and band stop. Low pass filter means it allows only the low frequency components to pass through. High pass filter means it allows only the high frequency components to pass through. Band pass filter means it allows the selected frequency range of signal to pass through. Band stop filter means it does not allow the selected frequency range to pass through. Just an exact opposite function of a band pass filter is band stop filter. So now in the case of in IIR filter which is called as infinite impulse response filter, you can see the transfer function, how the transfer function looks like. So it the transfer function it is represented as h of z. So it is equivalent to summation r equal to 0 to m b r z power minus r. So this m represents the order of the filter and the numerator we have the b coefficients and the denominator we have the a coefficients. So here it is in denominator we have 1 plus summation k equal to 1 to n a k z power minus k. Here in the denominator n is represents the order of the filter. So here the infinite impulse response filter, the transfer function is denoted by the numerator b coefficients and denominator a coefficients. So here the IIR filter is having feedback structure. So why it is having feedback structure? Whatever the output we are it is producing, that output will be fed back as an input side. So that's why even if the error is there, it will be fed back as an input to the input side. So that's why we call the IIR filter. It may not have some stable characteristics. So in the case of FIR filter, it's not having any feedback. So the FIR filter transfer function is given by h of z equal to summation n equal to 0 to n minus 1 h of n z power minus n. So if you see the digital filters design, it is very important to determine the transfer function h of z. So h of z is very important in the digital filter design. So in the concept of digital filter specifications, so first we'll convert the analog filter into an analog filter and then into the digital filter. So here, the one way for developing a realizable approximation to these filters is to truncate the impulse response for a low pass filter. So in this case of digital filter, the magnitude response specification is very important. That means the pass band and the stop band region, and the transition band is specified between the pass band and stop band. So if you see this picture, this is the magnitude specification of a digital low pass filter. So here you can able to see the peak ripple which is given by 1 plus delta p to 1 minus delta p, and the transition band. This is the transition band from pass band to stop band. So this is the transition band, and this is the stop band area, and this is the pass band area for the low pass filter. And we have the pass band edge frequency and stop band edge frequency. Omega p is pass band edge frequency, omega